So the next term we have is a pretty simple one. It's the term solve, which means after we substitute, we're going to actually use our algebra skills to rearrange well, it's going to be actually an expression, no longer an equation. Rearrange an expression, and we're going to use arithmetic to calculate a final answer for the variable the problem asks for. This is really important because a lot of people miss this. They just start solving for something and they don't realize that, for instance, in this last problem we have, the problem's asking for speed. So if I solve for something else, I'm not doing it correctly. There's a lot to this, and in another video, I'm going to talk more about exactly how to solve an equation, but we're going to move on right now. The next term is the word term. So sometimes if we just think about these terms long enough, they kind of make sense. In language, if you're in English, a term is just a word, and it's made up of letters. That's pretty obvious. So if that's what it means in language, the cool thing about that is that in algebra, it's pretty similar. A term is a grouping together of one or more variables or numbers. So terms could be a number, could be a variable or more than one variables. That's a term when they're grouped together. Really, really important here. Really important. Do not combine unlike terms. Ever. Never. Never combine unlike terms, and it's a really, really common mistake people make. Let me show you what I mean. So, for instance, let's say we start with this equation, VF equals VI plus AT. This is another equation that we'll use this year. Final speed equals initial speed plus acceleration times time. That's what that equation says. So let's say we substitute numbers in for these variables, and let's say the VF is 5, initial speed is 2, let's say A is 4, and we're going to solve for T. Remember, whatever we're going to solve for, I'm going to leave it the way it is in the equation. So we're talking about terms and not combining like terms. So once we substitute here, we get an equation that looks like this. 5 equals 2 plus 4t. This is a term, this is a term, and this is a term. Remember, just a combination of letters or numbers, one or more. So one number, one letter makes a term. You cannot combine these two, but lots and lots of people, when they start solving for this, they want to go 5 equals 6t because 4 plus 2 is 6, right? Wrong. Can't do that because these are not like terms. This one has a t, this one doesn't. It's like combining apples and oranges. You can't do that. What we're going to do here instead of that is we're going to algebraically rearrange this. So we start with 5 equals 2 plus 4t. Instead of combining those terms, we simply have to use algebra. We subtract 2. 5 minus 2 is 3. We bring down the 4t over here, and then we're going to divide by the 4, and then we are done. Now, if this didn't make sense to you, don't worry about this. I'm going to talk about solving rules in a little bit, but the point here is terms and not combining like terms. If the terms are the same, we can combine them, but that's actually going to be the case very, very seldom in this class. Do not combine like terms. The next term here, it has a little bit less to do with algebra and a lot more about physics. In physics, a constant is a letter, which is a variable again, that represents a quantity that never changes. In other words, it is constant or not variable. So that can be a little confusing because you're like, okay, so it's a variable that represents something that is not variable, Mr. Valls? Yes, that's exactly right. It's a constant. There's a lot of constants in physics, and these represent numbers. These are like universal things. It's like a thing that exists that will never, ever, ever change. All of these numbers are going to be given to you. Let me show you what I mean. So in physics, there's this really famous equation that Sir Isaac Newton came up with, and it looks like this. Fg equals g times m1 times m2 divided by r squared. This is the equation that describes gravity, universal gravitation. And this stands for the force of gravity. This stands for mass number 1. This stands for mass number 2. This is the distance between the two of them, and that distance is squared in the equation. But remember, we're talking about the word constant right now, and this little guy right here is a constant. It is Newton's universal gravitational constant, and it happens to have a value of 6.67 times 10 to the negative 11th. That number will never ever change. It's a constant, and it's given to you. Because I will give it to you in a chart, as a matter of fact, the problems that you're given won't actually have that number in there because it's a constant. You're expected to know it. And like I said, there are lots and lots of constants in this course. The value for the acceleration due to gravity on this planet is 9.8 meters per second squared. That's a constant. You'll probably never be able to forget this number actually by the time you leave this course. So there are lots and lots of constants in this class. And again, that's just a variable that stands for a number that will never change. Since I have this equation in front of us, let's go ahead and talk about these little doohickeys here that you might be wondering, hey, what's all that about? We use a lot of that in physics. Let me tell you what that is. So that's actually our next term, which is exponent. Exponent is a smaller script above a variable. For instance, in the gravitation equation, it was r squared. This squared, the 2, is an exponent. It's smaller. It's above the variable. We sometimes call that a superscript. Really important here, the superscript is mathematically relevant, which means it requires an operation. If there's a number that we substitute in here for this r, that number gets squared. That's what that number means. The r is squared in the equation, which means it's multiplied by itself. So the subscript, the exponent, is mathematically relevant, as opposed to the subscripts. And the subscripts, remember, in the gravitation equation, were m1 and m2. It's a subscript, so sub means below, super means above. Really important to know that, super above, sub below. It's below the variable, it's smaller, and it is not mathematically relevant. So it's really important to understand this, because a lot of people, when they see this m2, they start squaring it. M is not squared because this is not a superscript, it's a subscript, right? Subscript is only used as an identifier. The only reason we need the M1 and the M2 there is to differentiate between the two, just so that we know there's one mass and there's another mass. So a subscript is simply used as an identifier. The F with the subscript G in the previous equation, G just stands for gravity, because there's lots of forces: force of gravity, force of friction, the normal force. So the subscript is simply used as an identifier. So that's what the word exponent means.